Hi team and welcome to Getting Into Scanning. In our first video, we will dive right in and look at terminology. Scanning introduces many new terms and concepts that, by covering off right at the start, means hopefully it'll be easy to follow what we're discussing later on. We'll break this into two sections, scan terminology and office terminology. Starting with scan terminology, we're looking at the raw data and field terms used in scanning. Point cloud is as good a place as any to start. These are the points measured in a project. Station is a relatively straightforward concept as it's the setup of location of the instrument where the points are measured from. A scan in the point cloud is captured at a single station. A station can have multiple scans if needed, like a window scan in multiple locations. Registration refers to how scans join to one another within a point cloud. There are multiple different ways of doing this, which we'll cover in a later video. Registration sets are when groups of scans are registered or linked to each other in a project. Multiple registration sets can exist in the same project too, which can make viewing specific areas like a floor or indoor-outdoor areas much easier. Images are captured in most scanners now, and is generally a secondary process where the images are captured before or after the scan is done. This is what produces the panoramas at that station. Colorizing is a secondary process and gives the data a realistic view as the points are given a real-world color by overlapping them against the image captured at that location and assigning the point the associated pixel color. Levels scans are scans that have been determined as being leveled out in the field when the scan is captured. Leveled scans have the ability of knowing which way is up when being viewed, and the level is held constant unless specifically stated otherwise. Unleveled scans is when there is no level information stored or the scanner was not within level range at the time of scanning. The data in this case can be rotated all around with no predefined level. In putting this into practice, this is what we get. We have our point cloud, which is all the points that are in this particular project. From here, we can then turn on our stations. A station shows us which locations all these points were taken from. We can even view this so that we can see each of the scans according to an individual color dependent on where they are. This is the scans that were captured at each of the stations. Within this, we then have also the registration sets. So if we look at this, we've got a registration set for indoors, one for ground floor, and one for outdoors, which is clearly defined here. We have the panoramas that were captured at a particular station, and then we also have the intensity colors, where we have grayscale intensity, which is the default value, or color-coded intensity, which is just a colorized version of that grayscale intensity. Errors come in many forms, but are generally a mismatch in scan data. This can be small or large, and most errors can be minimized at the time of capture by using best field practices or can be addressed during post-processing. Refinements are a process undertaken after registration. This process looks at tightening the scan network as a whole to one another rather than just the individual scan station used in registration. When a scan is captured, generally every scan has a 00 setup, and registration will shift the scans outside of this to a location. Georeferencing moves that point cloud as a whole to a specific position, generally onto datum. For this reason, georeferencing should generally be undertaken after the refinement process and all the data has been collected in the project. Shadowing is what occurs when something is blocking the scanner from seeing the things behind it. It's the same as when you hold a torch up and shine it around, casting a shadow behind the object. This effect is an important consideration as no data is collected in this area. If the area is important to the project, then the scanner will need to be repositioned to collect the data there. Ghosting is when scans don't match up in registration. Generally, this can be seen in the scan data as multiple occurrences of the same object. This will be when errors are introduced in terms of meeting the control constraints. No matter what the process is or where it's done, every registration should be checked visually for ghosting to ensure that the best results can be achieved. Noise looks at how clearly something can be captured. There are different types of noise, like atmospheric, such as dust and rain, or noise from the scanner, where lower-end scanners may not be able to identify objects as clearly as high-end scanners. Noise should be a consideration as it will be driving force in determining your accuracies for the end project. Accuracy versus precision. We've all seen it and it's drilled into our understanding. during our survey education. However, let's cover this off once more to be sure. Precision refers to how close measurements of the same item are to each other, while accuracy refers to how close a measurement is to its true or accepted location. In scanning, we generally want accuracy over precision. We certainly don't want low accuracy and high precision, as this will give us the wrong result. Understanding your accuracies required is a very important aspect of laser scanning, as this will ensure you understand what your instrument is capable of and in turn understand what accuracies can be met. High accuracy and high precision results are generally expensive to achieve. However, it's also worth noting that other solutions might be a better fit to achieve the same desired accuracies. Next, we'll look at office terminology. The intensity values are the default view of scan data. Generally, when scanning, not only is the location measured, but also the intensity of the return of the signal. This allows things like road markings, which has a strong signal return, to be easily identified in the scan data against bitumen, which has a much weaker return. There is grayscale and color-coded, which both have the same raw data value. The software just assigns different colors for viewing. True color is once the data has been colorized against the panoramas. This view option is very good for showing off the data and making it useful and meaningful to a wide range of people. However, as it is a post-process step, it can result in objects like people being projected up against walls. Generally, for digitizing, the intensity values are better, and as a result, colorizing the data doesn't become an essential step until the end or there is a specific reason for it. Regions in scan data are like layers in CAD. By default, there is only one region with everything on it. This data can be broken up into groups, though, according to what it represents, allowing for things like ground points to be shown or power lines and power poles, hiding all other data. This can be a very time-consuming manual process. However, most software packages have an automation process that does the hard work for you. Regions make data processing significantly easier and allow the scan data to be put into a desired category for viewing. Unstructured and structured scans look at what's happening in the file when it's exported. An unstructured scan is just the point cloud. There is no station information, whereas a structured or gridded scan exports all the stations. Sometimes a single file is exported as a structured scan. However, most likely individual files are exported for each station based on their location at the time of export. So registered data can be viewed properly in external packages. Why is this important? Well, when opening a structured scan, you can turn on and off individual stations as well as see the data in station views. An unstructured scan won't let you do this. It's always best to check with the output end user what they want to make sure what is being exported is correct. Industry formats for scanning are different to CAD. While most packages won't stop you from exporting a DWG, for example, it's not recommended as the format is not designed to handle point clouds. For point clouds, we generally look at formats like E57, LAS, LAS, RCP, or PTS. Not all formats support everything like structured scans or classifications, so it may be worth working through with the end user what format works best for them. Another consideration here is scanning formats will only export the scanned data. CAD data, for example, will need to be exported in a CAD format. As always, thanks for watching and please feel free to reach out if you have any questions or want to discuss this further. Happy scanning!